Sir, I'm unable to open the modular app. I've
Software?
installed it already. Yes, sir.
What happened? What's the problem?
That text box is coming. You can find many useful examples.
Can you show me by sharing the screen if you don't mind? Is it possible for
Yes,
you?
sir. Sure. Sure.
Go ahead. Custody, did you practice yesterday class? Do you have any doubts in that previous section?
Sir, this is coming.
No, actually, this is not the way to open.
Sir, I'm trying to open it, but
Okay,
it
wait,
is
wait,
not
wait.
getting. Yes.
It is recommended that you use Python to run modular script. You have not installed Python.
Okay. I have installed it.
Python also installed.
Yes, sir. I have installed Python also.
See, modular software, we won't open modular software. It is useful for during when we do any modeling, when we run, it is the background software it runs. Okay. Now
Okay.
it is not required, but model you need MGL tools. Okay.
Hmm.
You have to run MGL tools. So the MGL tool looks, this is the Python modular viewer tool. Okay. This tool should be
Yes,
there.
sir.
And Python software, you need to install Python. Okay, if you have installed those things, it's enough. Okay.
I have installed Python also.
Sir,
Okay, I'll try to open that.
sir,
Yeah, Arvind.
sir, when I install that modular, it is asking for license key, sir.
Yeah, that what I had told you the yesterday also. If you have done, just ping me a message. I was asking you, no, so I can able to send more that the key for you. Okay, no issue, Arvind. I'll send you the key for you here in the chat box. Please look ahead. That's the license key. Is it okay, Arvind?
Just a minute.
You just install it by taking this key.
Yes, sir, it is installing. Thank you, sir.
Is it done now?
It is installing, sir. It is installing.
Yeah, fine. Then it's fine. Okay, no problem. Kasturi, now is it okay for you? Are you able to hear my voice? Kasturi, are you able to hear my voice?
Yes.
Now is it okay?
Yes.
Are you feeling any difficult?
Actually, I've done everything till creating the FASTA file, and after that,
Okay.
how
Can you
to
speak somewhat loud? Can you speak somewhat loud?
actually, sir, yesterday I've done the total chapter, and
Okay.
I've done till FASTA file creating. After that, how
Okay.
to create the 3 years old, no? The phylogenetic.
I
Yes.
yeah, phylogenetic
That
tree.
is in Crystal app or
Phylogeneity you should do in not in cluster. You should have to do it in
Mega.
uh, mega, right? Because this is not in our syllabus. Due to we had time, I just want to show you what is the difference of mega. Even Arvind was asking us about the difference of cluster and this one. So based on the interest, I'm also giving you because you people are interested. So that's why I'm teaching you. If you are not interested means I just going through my syllabus only. I will be completing. But though you people want to learn something new, so I'm also going out of syllabus to teach you because it will be useful for you, no, in some other place. That's why.
Hmm.
That
Sir, one
criteria I
more.
was helping. That's it. Hmm?
So one more thing. In the
Yeah.
cluster lab, there is a alignment option, no? In that you have
Yes.
said, no. First of all, we have to do output format option.
Yeah,
I did that and I selected all the things, and after that it's done. But how it's open?
I don't know what you're saying. Can you tell me? Repeat once again.
Actually, after cluster sequence formation,
Uh,
alignment formation,
okay.
there is no in the option of alignment. There is a output formation, output
Yes, yes,
format option.
yes,
And
yes,
after that, we have to select all the formats.
yes, yes.
I did it, and after that, okay. Then
Okay,
all the format files are downloaded in my folder,
okay,
but
okay.
they are not opening. In which format I have to open?
You
Any
can you show your screen then? What you have done? If I
yes,
see, I can able to know the error.
yes,
Can you show me later after the class?
yes, it's okay.
Now, shall we start our class? Okay. I think
Yes,
one more person should have to come, but we are running out of time because I waited already 10 minutes. Okay.
okay,
So I started recording also the class. Today class was very important. Please just listen. Be carefully listen. Okay.
okay.
Don't get confused. And Arvind, okay. I think someone has to do mute.
Mm,
Arvind. Okay, Arvind. Thank you. Okay, let me go for UniProt now. So we are going for UniProt database. UniProt database, it is also called as, it is used by scientific community people, by all the researchers to find the unique proteins and also the annotated proteins. So let me see something called a protein name, uh, something the ID I just give here. Think this is something called a rhodococcus. There is a high molecular weight, nitrile hydride synthetase. Okay, I have chosen something called nitrile hydride synthetase. So think there are many proteins are available, but for this particular protein there is no structure is available. Okay, so see here there is no structure. Structural information is not available. Are you able to see the structural information is not available here?
yes, sir.
Okay. So see, I want to perform blast. I can also perform here also. So all of you, if you have pen and notes, can you write down everything, whatever I'm saying? So this is a very important thing. Whatever I'm saying, you have to note down before when you are going for alignment. So please note down whatever I'm saying to you. So note down, when you go for Uniprot, you have to open this sequence. Just click the sequence. After that, you have to go for FASTA sequence. Okay, you have to open the FASTA sequence when it doesn't have a structure. Okay, we are building a 3D structure now, homology modeling. So what I'm doing here, just go for this particular place that is called FASTA sequence, and also note down the sequence length. How much the sequence length was? Sampada, what is the sequence length?
203.
Yeah, note down. Okay, is it clear? Okay, then let's go for blast. I just want to perform blast with a 3D structure, okay, from PDB database. So I'm running the blast here. Let's perform blast because we want to find a template structure. So do you all remember we have a target sequence? We want to find a template for that one to build a homology model, right? We want to build a model. We want to make alignment means we need a template structure, okay? Then only we can do alignment also. So we will see our PPT also that then it will make something very easy to understand. So let me see this one. All of you can able to see this one. We have a template sequence. Now we are performing blast to find the template structure. Okay. By compiling these both structures, we perform homology modeling. Okay. And we build a 3D structure. Now there is no 3D structure for this particular protein. Now what I'm doing, I want to see the similar protein for this particular species. So let me see which is having the high unique alignment. Okay. So you can see here the alignment has a, well, yesterday I told you that when we perform blast, our identity should be more than 30%, right? All of you, do you have any, do you have idea, right? What I'm saying? about identity information.
Yes.
So our
Yes, sir.
identity should match with the template target sequence also.
Should be above
So you can,
30%, sir.
yeah, this can you see now the identity is 58% here for this particular protein, right? This is identity has a 58%. Let me see this particular sequence information. So let me take this sequence outside. Let me see what is the organism pseudonocardia thermophila. This is also belongs to cobalt containing nitrile hydride subunit alpha. Let me see it has any structure or not. Yeah, it has structure. So you can see there are number of structures were available here. Can you see here? The structures are available. More number of structures are available. Okay. So there are number of structures are available. All are in the position where crystallized at the position of in between of 1 to 204 only. So we can
Sir,
choose
these
any
are
one of the
available in
structure.
Uniprot itself, sir.
Yeah, Arvind, your voice was not that much audible. Can you
Sir,
speak clearly?
this is available in Uniprot itself. This one.
Yeah, if you do in Uniprot Blast, it is available there only. If not, you can also perform Blast individually. Okay, I told you there is a Blast another
Yeah,
method.
Blast,
Okay, you can go in this way. Go for Blast,
NCBA Blast.
not NCBA Blast, only Blast. You can do only blast
Yeah,
TP analysis.
that site name I said, sir. NCBA.
Yeah, NCBA blast, we call them as NCBA blast only. But in case of NCBA blast, there we do nucleotide also, no? That's why I spoke. Okay, you can paste the UniProt ID or FASTA
Pasta
sequence here.
sequence itself we can take it, yeah.
Okay, just what I'm doing here, I just click here, it will rectify the place. And in the database, we need to select the protein database. And here we need to give the organism. If there are more structures are available at the criteria, which particular ID you want to select. Okay, for the purpose of doing the selecting a template structure, in that criteria, you have to choose the organism name. So this is the organism name for that particular we have chosen, which is having more identity, right? So what I'm doing here, I just given the this organism name here. Okay. And I'm performing blast. Let me see the blast analysis results, what it comes in the here also. So sometimes it takes time because there are number of PDB structures are available. Now that's why it takes individually when we run with the blast. When you do here itself, when you perform here itself in the UniProt, it takes very less time because already PDB structures are available in UniProt also. That's why it is giving in a short time only the results analysis. But here in case of blast, it should have to read it to PDB database and it should have to get the results. Now that's why it's taking time to us. Okay. So let me see which structure is available. Let's wait for the patiently for the target sequence to understand. And before that, you have to make a folder. Yesterday we performed drug designing here. Now what I'm doing inside the folder, I'm creating another folder called HM. That is called homology modeling. Okay. I want to create a text document because I want to paste my FASTA sequence. It is taking some time. Let's wait for that one. So I have to paste my FASTA sequence. So take the FASTA sequence. Paste the FASTA sequence. And we want to wait for our template. Still it is generating. Or else you can also choose from here also. No need to go there because I am just waiting to show you the difference of the structure. Okay. So we can also choose, there are similar IDs are available here. You can see here, that is 4BO, 4OB1, 4OB2, which is having the lesser residue. You can choose lesser in ID. Okay, I mean the lesser in ID means lesser in resolution. You can choose that one. When you come to the lesser in resolution, you can see there 1.52 is having the lesser resolution and 1.20 is also having lesser resolution. So you can choose this one also. Okay, that is 4OBO. So let's open with this particular ID 4OBO. So still it's you have to have 14 seconds. It takes time. So can you see this one? This belongs to crystal structure of a nitrile hydratase pseudocornoidea thermodale. Okay, it has any structure or not? Let me see. So it has any crystal structure. So it has a crystal structure called phenyl boronic acid, and it is also having cobalt ion. Okay, so for building any template structure, we have to download the two files. Those are very important. Those are FASTA sequence and the PDB format. Okay, I am going to download the FASTA sequence and also I'm downloading the PDB format. Is it clear up to here? Is it clear up to here?
Yes, sir.
Yes, sir. Sir,
Yeah,
you have copy pasted the sequence. It is of unknown structure or known structure one.
it's unknown structure I pasted. Now I'm taking the known structure from
Okay, sir.
PDB file because we generated blast. Now we are taking that one.
Yeah. Okay.
Okay, see now I saved here. I already opened a sequence here. That is our Uniprot ID. That is P1219, right? And I have an ID called PBOO. Now I have downloaded FASTA file also individually from PDB, right? So what I'm doing, I will open the file. Okay, I will take this one chain. These both chain are similar. So that's why what I'm doing. So I just take this particular chain. That is this one. Okay, let me take this particular chain. This is our template target. See, this is target, this is template. So now we have already pasted our target sequence. Now I am just taking the template structure sequence, okay, to make alignment. Okay, what I am doing here, just I get down here and I paste here. Okay, it is in which document file format? It is in text document. So I need to change in which format to if I want to make alignment means.
Sir, now you have pasted both the sequence, no known one and unknown
Pasta,
one.
pasta format, sir.
Yeah, right, Arvind. Yes. What about Sampada? Are you following me?
I didn't get that 1 minute thing. You just copied that sequence and one of the sequence, one chain, and then you pasted it in the earlier text document, right?
Yes. This is our known sequence. This is our known sequence. These are unknown sequence which it doesn't have the structure. We performed blast for this particular sequence. So we have got this sequence having the best identity. We chosen one lowest resolution PDB ID FASTA format. Okay. And
Okay.
now I have pasted as this one as a template, this one as a target. Okay. Now
Okay, sir.
I'm just saving it as in FASTA format. Okay, you have to give the strings always. So one
Yes.
was the template, other one was the target. So I paste it without getting confused as TT, right? TT FASTA format. Is it clear now? So I just close this one. Now let me see whether it has saved or not. So can you see now the FASTA format has been saved in TT.
Yes, sir.
So this was target, this was template. I saved it. So now we have to make the alignment. So we can't do alignment in Mega. We can able to see the alignment, but we can't see the output format option. In that criteria, what I am doing, I'm just going for cluster. So go for cluster X. So go for file. What I should have to choose? Tell me.
Load sequence.
Load
Okay.
sequence.
Let me
Select that
load the sequence.
FASTA file.
FASTA file. Which one? This one or
Which
this one?
we
TT or new
which
doc?
created.
TT, right?
Yeah.
Okay. And let's increase the.
It is
See,
the
there are
font.
more number of fonts or more number of identical residues. Identical, this is similar. This is also similar. This has somewhat conserved. Okay. Now what I have to do? I have to go for alignment, and which option I should have to select?
First, select the output format option.
Yeah, I have to select
Select
all,
all
right?
the formats. Yeah.
Okay. Okay. Then
Then go to do complete alignment.
yeah,
Okay.
now alignment has been done. And what
Yeah.
I should have to do now?
So
Right
after that,
alignment as
how the
post-it.
files will be open? Actually, they are not
Yeah.
open. I've
See, I'll
done
show
till.
you. Right alignment as post-it file. Do it. Okay. I've done, and go for save sequence. Right.
Once again,
Completed.
once again, please, sir.
Go for file, save the sequence. Later go for right alignment as post-it file.
Yeah, I have done also.
Okay. Just closing these all things now. So can you see now these all files has been generated?
Hmm.
Is it clear? So
Yes.
now I need, if you want to see the alignment picture in PDF, you can double click this file, PS file. It will generate the PDF. Okay. Because I don't have PDF, that's why I'm unable to open this one. So now we need to go for alignment. We need to make alignment this particular file. Okay. What shall I do? I open this particular file now. So can you see now alignment file? You can see this is the
Sir,
alignment file of protein information
yeah.
resource. This is the PIR file, which we
This
have
is
chosen
in
in our,
WordPad.
this is the PIR file, PIR. So this one, the last one, last to second one, PIR. I just, can you, oh, this doesn't shows. This one, right? So I have opened the PIR file. I need to remove all these things, unnecessary things. First, remember, you have to remove all these unnecessary things. Okay. Okay, I removed everything. This one is our
Sir,
uniprot
you have
sequence.
opened PIR file, right?
Yes, yes.
It's opened in WordPad.
If you double click, it will open in WordPad. If it is not there in WordPad, the all defaultly you open it in WordPad. Okay.
Okay.
And now you have to give here. This is our uniprot sequence. This one, our PDB sequence, right? That's the target sequence. Now this one we need to name it as sequence. S as capital, remaining things are in small letter. Okay. Sequence. That down one as a structure, because this belongs to structure file, na? Target sequence structure. So make it as X, because we are generating a external crystallography structure. Is it okay? Are you following me?
Yes, sir.
So now we need to make 9 columns. We want to make alignment 9 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here also similarly we should have to make 9 columns. When we want to run a Python script, we are asking, we are aligning everything according to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it okay? We have to take 9 columns. Okay, why 9 columns? You may have doubt. So let me show at the end for you. So here, as it is, whatever the ID is there, just paste it, because the first column we are giving is a uniprot ID. Okay, and what was the first starting ID? ID starts with ID starts from where? Let me see. ID starts from 1, right? 1 to it ends with 203, right? You have to note down these all things before you are going to homology modeling. This is the first starting 1 to 60, 1 to 50. Again 50 to 100. These are available. So at the end, the total length sequence was 203. The first starting chain starting with first chain and ending with the 203 chain. Is it okay?
Yes.
So the first starting chain was, so the first residue number, what, how with which number it is starting? First number, right? And it's starting with A chain. It has only one chain, that is A chain for faster sequence. Always it is default. And ending chain is ending with what number? You have noted. I have shown you the length of the total chain, ending chain length. How much it is?
203.
Yeah. What is the ending chain? It is A chain, right? And we need to make resolution when you're designing anything. So make it as resolution default minus 1.2.0. This is the default resolution we are giving. Now we want to know this ID, the PDB ID. This is the starting PDB ID, and we don't know what is the starting chain. So for that, you have to go for, you have downloaded a protein data bank. Okay, you have to open this protein data bank with Word. If you open with Word the PDB file, you will find the starting chain. So let me show you the fast starting chain. Just get down, just scroll down like this. So from where it is starting? What is the residue number here? 2. That is threonine, right? And where it is ending? Let's see. You have to see the termination chain now. Just scroll down like this. So it is ending with a 204. Okay, have you noted? Noted? It is starting with 2 and ending with 204. You have to remember always the termination tells us it is the ending chain. But B chain is starting from 1. So we have not chosen B, we have chosen only A. That's why we are taking the A chain here. Okay? Is it clear?
Sir, please explain again.
As you have chosen the chain residues, the starting residue and ending residues in Unipro, you have to make it sure that you have to name here the starting chain and the ending chain also. Okay? We don't know the ending chain and starting chain. We just downloaded the PDB file format. Okay, we have downloaded this particular PDB file format at 4OBO with the download FASTA file and FASTA sequence. But we don't know where the starting chain and ending chain is it is there. The numbers, residues, we don't know. So if you want to know the ending residues and starting residues, you have to open the file which you have downloaded, the PDB file. This is the PDB file. You have to open in Word file. If you open with the Word file, you will find the ending residues and the starting residues. Okay, so for in case like ending residues, it has two chains. So the termination, the word termination calls as the chain is ending here from here. So you have to open the file format, PDB file format in that WordPad. Then only you can able to understand where the residue is available. So this is the 204 residue of the ending chain, and the starting chain was second. So you can see the second chain also here. So you have to get scroll down when it starts with atom. So see, this is the atom with a threonine 2. So can you see the threonine here? You can see threonine here, T. The second one was threonine. Okay, the ending one valine. Ending one was valine here. So sorry, here it is the valine. Is there still any doubt?
No, sir.
Okay, is it clear? So now we need to align. So what is the starting chain now? It is 2, right? And what is the chain we selected here? There were two chains were there in PDB. We
Yes.
selected which chain?
A chain.
Yeah, A chain. That should we should remember this one. A chain. What is the ending chain here? Ending residue. It was
204.
Yeah, and the ending residues or ending chain is also A. And this
Yes.
one was the default. You have to remember these all things. Up to here, is it cleared?
Yes.
And what about Arvind? Are you getting what I'm saying? Arvind, Sampada.
Sir, yes, sir.
Sampada, what about you?
Sir, I got it.
Yeah, fine. So now
Sir,
we need to
One
Yeah,
question. Why are the middle three colons left
those
blank?
are default. Those are default.
Okay.
Okay, those are default. That's it. Okay.
Yes.
And now we need to see some missing residues will be there. Whenever you are whenever you are crystallizing any three-dimensional structure, some type of residues will be missing. So for that particular residues, you need to find what are those missing residues. When you open the PDB file, okay. Oh, sorry. This particular PDB file, when you open with 4OBO, when you open with a Word file, you can just give Control F. Okay, give Control F and search as missing. Okay, you will find missing residues. Got it? So did you find the first one was the missing residue for this A chain? Shall we see whether that A chain has one or not? Because our residue where it is starting, it is starting with 2, right? See, it is starting with 2, but first residue was missing for us during crystallization. Are you able to understand what I said?
Yes, sir.
Yeah. So for us, it is not required as this methionine. That's why we want to remove this missing residue. So we blindly we can remove this one. Remove and just make it as give as a gap. Because if you don't give this gap, what happens? See, this alignment is not matching. Can you see this alignment was not matching? Wait, just increase. Can you see the alignment is not matching here? There is some gap after I'm removing the methionine here, the first residue. To fill that gap, I'm just giving a gap residue. Have you seen there is a gap when we have done cluster X also, there are some residues were not matching. They are arranged with this type of dashes. Those are called gaps, gap penalties. Okay.
Yes, sir.
Now there are few other residues are also available. Those are there are now 205, 206, 207, 208, 209. Those are in serial in number. But if you know the 3-digit amino acid code, then it is very easy to go for modeling to find the missing residues. But here all the residues, all 6 residues are histidine only. So it is very easy to identify where the 6 residues are available, right? So I need to find where the 6 residues, but here it is already available. But in case if you don't know the 6 residues, just find it like this. It is available. Got it? And I need to remove these 6. 1, 2, 3, 4, 5, 6. I given 6 residues. Is it clear till here?
Yes.
Now we need to save this file, this PIR file. Though saving the PIR file, it should be saved in the text. The document file should be saved in ALI format. Okay, we have to save it in ALI format. So just save it with tt.ali. ALI stands for alignment file. Okay, I'm just saving. I'm just save as. So let me see whether it has saved or not. Would like to see there is a file called ALI. Okay, what we have done the alignment file. Now you is it okay? Is it clear? It has been saved in ALI. Got it? Whatever alignment you have done, whatever residues you have given, you should have to, after completing everything, after making missing residues and everything, you have to save that file in ALI file format. Okay, that's what I'm saying.
Yes, sir. Got it.
Okay. Okay, now we need the file to be, we need to run the file. So for that file, we need a Python script that is already available. So just type in Google homology model and you will find the Python script. And let's give us Python. So you'll find tutorial Andres Saheli, the name called tutorial Andres Saheli. Just go down. You just go down, you'll find something a default one, this particular default file. Okay, just save it, take this particular default one, and just after taking to build a model, okay, to build a model structure, you have to select this all. This is the default file which is written for to run a model. Okay, and after that you come to the text document, save it. Okay, just remove these all the necessary things to avoid disturbance. So save as. So whenever you are saving, you name it as script. Okay, that the extension file document file should be in py. If your Python, if you have installed Python, you have to save all the files in py format. That's why I'm mentioning as .py. Okay, so if you mention py, it will show us in the Python script if you have already installed, as how your pymol is visible when you download a pdb file format. Okay, now I am saving this particular file. So after I'm saving, see, the Python script has been generated with this following icon. If you also have that Python script, you will able to run the file. So this is the Python script file. Okay, I will send this one in our chat box if it is possible. If you have doubt also, I'll just send this ID to you. So don't get confused. Just save it. I'm sending in the chat box for you. Okay, now I need to align this particular file. Okay, now I need to open this particular script, Python script. Okay, so just right click and edit with IDLE. If your system is 64-bit, open with 64-bit. If your system is 32-bit, open with 32-bit. Okay, and just open the Python script, this one particular file. 1 minute. So this particular. Okay, what is your known PDB ID? It was you saved. That's PDB structure. Your sequence number, sequence was
4OBO.
that's P2, yeah, 4OBO, 4OBO. You have to save it according to how it was here. Okay, and also what is your Uniprot ID? It's P1219. P2129, right? I think that one.
P21219.
Something called P21219, right? Okay. Now, in which format you have saved it? The extension name was. It is TT ALI, right? You have saved in P2 ALI. And also you can generate 100. If you want to generate 100 models, you can generate 100. Or else if you want to generate a 300, you can generate 300. Or else if you want to generate 25, you can generate 25. But defaultly, we have less time. That's why I'm just going for 5 models to show you the result. Okay. And after
Sir,
that, yeah.
sir, is it 4OBO or 4OB0?
Oh, 4O, this one. Sorry. Yeah, thank you. Fine. Thank you,
Yes, sir.
Sampata. This is very important. In PDB structure, sometimes what we do, sometimes 0 we type as O, sometimes O we type as 0, then it never runs. Okay, so just save it. Okay, after saving this particular file, so go for Python script and try to run the file with the go for run, and go for run the module. Okay, I'm just running. Now is it clear till here? After before running, I'm just asking you. Is it clear till here?
Yes, sir.
What about Kasturi and Arvind?
Yes, sir.
Arvind, is it okay?
Okay, sir. Okay, sir.
Yeah, I'm running C file. So as I started running the file, oh, see, we got some error here. There is some problem. It's
Sir,
in
you
running the.
typed 4OBO. but it is
Yeah,
40B0,
the thing
I guess.
was, see here, the problem was here I saved it in B capital, right?
Yes, yes.
So let me change that one. Okay, I saved it. Again, I'm running. Oh, again, there was some error. So what was the error here? Can you see here the error was, we need to rectify the error. When you go for anything, doing the alignment chain, so the error was there, see the residue 2 was 16 here it seems. But the 16th residue is serine here. But 112 chain is showing in the A chain was, it was serine. Let me see the PDB file. We need to rectify the PDB file now. Let me go for PDB file, open with the WordPad, and let me see the error file. What was the error? It is saying that the second one was the cysteine, but you are saying that 16th residue was serine. So let me see what was the error. So let's see what is the C here, second residue. Second one was threonine, right? And let me see 16. 16th was a glutamine. Let me see 112. Then can you see here the residue before 111? So there is a residue called cysteine, right? In alignment file, there is a residue called cysteine, that is 110, 110th alignment position. So let me see the file, I'll show you. Oh my goodness. Can you see the 110th position? After 110th position, there is no such type of residue called CSD. Okay. So this is not matching with that particular residue because there is no such type of amino acid called CSD in amino acids. So this is, we need to rectify it. This is not CSD. This is called cysteine. Cysteine. So you can find in Google also amino acid cysteine codon. Cysteine. So amino acid cysteine stands for a 3-digit codon is, right. So can you see now it is CYS, but what it has been generated when in crystal structure, it has generated as CSD. Got it? It should be like CYS, but it has generated CSD. So we need to rectify this particular thing. That is called, we need to make it as CSY. So everything unity chain is CSY. Change it CSY.
Excuse me.
Sir,
Yeah.
It's a
CYS, na?
CYS and not CSY.
CYS.
Oh yeah. Sorry. I was a bit confused. Yeah. CYS, right? Let me save CY. Yes. So whenever they do crystallization, sometimes the crystallization happens like this. So this is defaultly happened in the PDB database. So we need to change those things. So until wherever it has been there, till there we need to change. So that's why it is not reading. Okay, till now we have changed everything. And we need to save this particular file. We have to save it. Just close. Again, go. Just close this file. Open the file. Again, run the file. Okay, there was some problem. is the problem? So please give me some moment to check the error.
Yes, sure.
Okay. The thing is, it's 16. There's a mismatch here. Let's see. So please hold. I just want to reinstall it my software once. Just hold one moment. So will you all please wait? Is there any work? Can you wait once again? Shall we run once again the script? Is it possible? Can you wait?
Yes,
Yes,
sir.
sir, I can wait.
What about Preeti ma'am? Are you going to wait? Yes.
Yes, okay.
Mm. Because we need to run once again. That's a problem.
Okay, no issues.
we'll run with some other ID. There's a problem with this ID, so I'll just share the screen for you. Yeah, okay. So let me do once again. So we have done blast also, right? Previously we have done this. We have done the what we know. We done blast in Uniprot, and we are going to do blast here in we have done in protein blast. Okay, and after the result analysis, we have got this representation. Okay, so let me show you something called here. When we do alignment, as I told you, we want to choose any template structure. Okay, we want to choose template structure means we have to perform. Sorry, we want to perform. We want to choose any PDB ID means the template structure means we have to go for blast analysis. In this, you can see the query coverage is 91% for all those things. That means the identity. So the identity shows for everything. It has the first four has a 58%. Okay. In this criteria, we need to choose that 1E85 and 1E84 has lesser E value. Okay. So this has a lesser. What I mean was lesser in choosing the identity. So we can choose 1UGQ or 1UGS, your wish. But we have chosen 4BO, okay, previously. So let's go for, let's do once again with this 1GUQ, okay. So it is also having query coverage. Maximum score it has covered to 242. That's why I'm choosing this one. But in case this one, this is also this has also having lesser query coverage, total query coverage. That's why I chosen as this one, 58%, which is having the 91% with lesser. So let me open 1UGQ. Okay, that is 1UGQ. So I need PDB format. I need FASTA sequence. Okay, up to here, let's copy these both files. After copying these both files, just come here and delete the remaining things, whatever here it is there, except the script file. So, I deleted, just pasting the remaining things, pasted. So let me save this one. It is having, this is having capital, and other one was not in capital. UGQ. So which ID we have chosen here? That is a chain here. This represents the chain. The ending one represent the chain after the PDB code. Okay. So I want a chain now. So I need this also. That is our the sequence. Sorry, where it is. This ID also, we need this one, or Uniprot sequence. Just paste it here. And also I need the FASTA file, that is a chain. Let's take a chain. Okay, we want to do align, we have to do alignment. I'm saving it as in FASTA file, tt.fasta. This is the type of document is I'm saying in FASTA. I'm closing all those things. Okay, I just closed, and I want to run the alignment. Go for alignment, open file, load the sequence. Okay, and go for this particular file, like designing, go for file script, select the FASTA file. Okay, after that, do output format options. I need all the output format options to run the homology modeling. I click, I do the to complete alignment. I have done alignment. I am saving the sequence. Okay, after that, generate the alignment as PostScript file. Generated. Just close it. After that, open PIR file. Okay, remove the unnecessary things, whatever there here. Okay, and also remove these all things, and make it here as sequence. Okay, and give now 9 columns 1, 2, 3, 4, 5, 6, 7, 8, 9. And here give a structure. Give 9 columns here also. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here we need to give our ID, the input ID, the first one. And the starting chain was 1, and the starting chain is A chain, and the ending chain was 203, and the resolution was minus 1.00. Sorry, it's an A chain we need to give here. Minus 1.00. And here we don't know what is our your new GQ. We don't know what was the starting and ending residues. So let me check. So open with PDB. Open with PDB. Just come here. Just scroll down. So it is also starting from 2. Okay. And what are the ending? Ending is starting from 204, right? So let's re-edit these all things. So it is 1 U G Q, and it is starting from 2, and the first chain was A chain. Because why I have kept A here? See, the blast analysis showed us it is A chain. It has told us A chain. That's why I chosen as A chain. Okay, A chain. I'm going for the so length was ending was A 204, and ending chain is also A. So 1, 2, 3, 4, 5, 6, 7, 8, 9. One more colon. I forgot it. Minus 1.00 minus 2.00. Okay, have done these all things. Now we need to edit the missing file formats. Okay, so let me give Control F. Missing. So there is no missing chain for this particular residue. That's why it's not showing to us. If not, we would have been done missing residues also. We are finding missing residues. If there is no missing residues, we can directly perform homology modeling running. We can run them. Let me see if there are any missing residues. No missing residues are there. So we can save the file directly. No. So let me save the file. Let me save the file in TTALI. Okay. .ali. Okay, I saved it in TTALI. After that, close these all things. Open the script. Make it this one as 1 UGQ. UG. Okay, then save it. After that, go for run. Oh, then there was a problem. 14 cells by align code was not found in the alignment. P21 21219. Okay, I have removed the colon. That's why it has not run. Okay. See, after I'm running. Okay, sorry. I'll run once again. Sorry. I want to show you the error. No? So see here in the alignment file, what I have done, I'll delete these things, so you'll get an idea. Sorry, tomorrow I'll show you the other method also, homology model. So I have given a bar colon here, na? It was there like this, so I have to give this colon. Okay, I have given this colon, I have saved it. That's why it is running now. Okay, is it clear? So I'm closing this all thing. Now I saved everything. So what I'm doing here, I'm just go for run and run the module. So whenever you run the module, can see the models are generating. I have given 5 models. Okay, I have given 5 models. Since I have given 5 models, see, as long as the 5 models runs, the best model will be generated among these. Now you can see directly here, the 3-dimensional model, 5 models will be generated automatically. See, the first model has generated and the second model is generating now. Are you following me? Are you understanding what I said? Now the Python script is running automatically. Hello.
Yes,
Yes,
sir.
sir.
Is it clear?
Yes, sir.
What about you, ma'am?
Yeah, it's clear.
Arvind, is it clear for you also? Kasturi, ma'am, is it clear for you? See, now 5 models were generated. Okay, can you see here the 5 models were generated? Previously, we don't have model, right? We taken the reference model as 1GQU, okay, after the performing blast. And we can see the dope score has came. The dope score is also called as discrete optimized potential energy. So I told you the previously also in our class section. So we design dope score, and later we have to model validation. Based on the model validation, we have performed model now till here. Okay, now you need to choose the best one now. Okay, you have to choose the best one which is having the highest energy. That tells us the best model. So among this dope score, the best score was this one, which is having the highest energy. That is the third model. Can you see the third one here? This one is the best model. So name it as the best model. Save it. And further you have to give for model validation. Okay, just open this particular best model by double clicking. If you have already installed PyMol, it will show you. So just go for show action ribbon, hide the lines. So you can see the model has generated. We have generated a model. Got it? We can also see the struct sequence. And you have to save this particular dose score also by taking screenshot. You can give for a reference as you chosen the best model, as how many models you have generated. Till here, is it clear for you?
Yes, sir.
Priti ma'am, what about you? Arvind, Sampada?
Yes, sir.
Yeah, the number of model depends upon.
Yeah, you can go for 100 also, not issue. But in case
Okay.
of our demonstration, we don't have time. Na? In our 1 hour time, we need to go. Na? That's why I go only with 5 minutes. Okay.
Okay.
Okay, till we have generated a structure. Okay, till here we have done our work. Till here we have done now. Till here we have done completed homology modeling. Now tomorrow we do project, prosa, proq. And later we go for grid generation and the next week classes. Tomorrow is our last class. Next 2 and Saturday, Sunday we don't have classes. Okay, and we go for the docking. All these things will be done. Okay.
Will the recording be sent? Recording of this class be sent?
Every day it is available in the user ID. It is provided to you. Okay.
Okay.
Every day I will be provided the recordings to you. It is available here. You can find here. So today's recording has not yet uploaded. It will be uploaded by tomorrow morning for you. Okay. By
So,
9 p.m. it is available for you. Okay.
so these recordings will be active lifetime, or after the classes it will be.
No. It is available for lifetime also. until the read my course
Is there?
is the organization is there till there. Okay.
Okay. Thank you.
So is there any doubts? Are you facing any difficulty about learning homology modeling? It is very easy or difficult for you now?
Yeah, it's a little complex, but have to practice. After that, it will be easy.
Yeah. What about you, ma'am? Preeti ma'am.
Seems like I have to practice more. Actually, I joined a bit late today.
No problem. Recording is available for you.
Okay.
Okay. Tomorrow
Yeah.
also we will teach you homology model, other model. Okay. You will feel
Fine.
very happy for learning that one also. Arvind, what about you? Is it okay?
So one doubt is there.
Yeah.
Actually, we were searching for missing sequences. No, in which file you have you search for missing sequences?
I don't know what you're saying.
Actually, after pasting both the sequences, we were searching for missing sequences. No, missing residues.
Yeah. If it is there, I will show you tomorrow that one. Okay.
Okay.
That one I will show. That part I will show you tomorrow. Okay. Today there was a problem with that Uniprot ID. That's why I'll show you tomorrow.
Okay.
Okay. Fine. Shall I leave then?
Yes. Thank you.
Okay. Bye. Take care.